trying to get a second root of a complex number. And according to Mauer's theorem, it has got two values. In complex plane, it would quite probably look like that you have subtracted here some imaginary part. Most programs that produce a square root of a complex number will return you one value, and it would be this, mostly. Of course, there is a second value, which is just opposite on the unity circle. So, in fact, you will get mostly, if you just use a square root in Matcat, MATLAB, I don't know where, you will mostly receive a kx which has a positive imaginary part. And therefore, you would get a correct result, but not always. Sometimes you get the other solution, depending on the ratio of material properties, and you can also get out of that square root this solution. But in that case, this wave would increase when increasing the distance from the waveguide. So you should check in each step during the solution, whether you receive the correct root of the square root. And, well, in this case, in fact, it is sufficient to require that you have a positive alpha in the x direction. So this is something that would force your calculations not to work. Surprisingly, because the equation looks perfect. You have the square root of the correct equation, just square root is in complex domain a function that has a main and an additional value. So that's the first point I would like to raise. The second point is a bit more tricky. Just imagine that you have, again, the waveguide or that structure. It might be an optical structure guiding light. That's the same situation. And now this part is lossless. This part is quite lossy, but not an ideal conductor. Now in this case, the attenuation within this part of the structure would be quite big. And you have to care about one problem. You have seen sines and cosines, but kx might be a big number and has a big real, or can have a big imaginary part. Now, sine behave periodically for real numbers, but turns into sine hyperbolicus for imaginary part of the argument, so that it could be growing exponentially. And the point is that if you have this situation and you simply input here a, you have quite a big number which will overflow your computer. So the solution for a planar structure is to have separate coordinate systems, so that you consider here the distance from the x. Here you introduce an x with apostrophe, which is x minus A, so that you have the zero here, that would not overflow your calculations at this boundary. And yes, just remember, this is on another sheet of paper, this distance was A. And of course, outside, you would make an x with two apostrophes, which are a real x minus the distance b. This would cure the problem mostly. It is quite important to use full precision. That is the type extended if you program that in a higher language, and not to use only single precision. That would ruin your calculations for sure. And this is the second remark I wanted to do for the implementation. Now I will put into this Teams group two files today. One of them is a PDF produced from my old MathCAD program that solves this, including some pictures. The second one is a derive program, a derive listing, which gives you the derivation of all field components and possibly even a pointing vector or something like that within the structure. So if you tried to put it down, that's a good idea, but all the equations are somehow described in a text form. Derive is an old text program, in a text form, so that you will get it. But the important point today was finding possible solutions, suing them and the boundaries, and finally getting the characteristic equation, which is a linear equation of parameters non-linearly dependent on the propagation constant, and searching for zeros of the determinant of that system matrix, which provides you possible solutions to the field. Now, gentlemen, your questions? There are no questions within the chat. I can't hear any question. So, gentlemen, it's been a pleasure to teach you today. That was the first spring lecture of computer-aided electromagnetics. Looking forward to meet you next week. Wish you good luck and a nice, pleasant spring, possibly with some more possibility of movement in next weeks. See you.
Thank you very much. See you.
Thank you.
Bye.